everyone, this is Zhibing Guo. I'm one of the application engineers at Betasize. In this talk, I'm going to give an introduction to the fundamentals of a very powerful particle size analyzer, Betasizer 2600. This talk has 6 sections. First, I'd like to talk about a few fundamental concepts about particle sizing. Then, I'll move on to the analyzer and start with optical setup. Next, I will show its modular design for fast and easy switch between wet and dry dispersion modules. I will walk through the wet and dry measurements respectively, with respect to demo, principal, and important nodes, etc. Last but not least, as a highly automatic instrument, Betasizer 2600 owns intelligent functions and powerful software, which will be explained in detail in the last section. Before we dive into the sophisticated optical setup, let me do a brief introduction to some fundamental concepts. Have a look at currently available methods of particle sizing. Since the 1970s, laser diffraction has become one of the most important and widely accepted methods for the determination of particle size. Laser diffraction is suitable for measuring nano and micro-sized particles, with a wide size range covering from tens of nanometers to several millimeters. With laser diffraction, as we know, laser is coherent and almost monochromatic. In other words, it consists of light of one wavelength. If it hits a particle, then depending on the size of this particle, different physical effects occur, including diffraction, refraction, scattering, and so on. So laser diffraction is a method based on the deflection of light at particles. These are the diffraction images at different particles in two-dimensional and three-dimensional view. If we visualize the laser diffraction as such an object in forward direction on the screen, a diffraction pattern with several intensity maxima and minima is created. A larger particle diffracts the laser beam less than a smaller particle. So, the light spectral diagram of the small particles must be recorded at larger angles by detectors. On the right, the scattering diagram on multiple particles that contains numerous small and large particles is shown. How do we record scattering diagram? With the help of photoelectrical detectors installed at the focal plane, light signals can be recorded and translated to electric signal. Then, by applying the rigorous Mean scattering theory to the data and mathematical conversion by a specialized software, the particle size distribution of a sample can be provided. Okay, with the knowledge of some fundamental concepts, let's dive into the optical setup of the Betasizer 2600. It's a particle size analyzer based on the principle of laser diffraction. It can measure the particle size of suspensions, emulsion, and dry powders. It is such a sophisticated instrument that many system parameters are listed in this table. But today, I'm not going to talk about these tedious numbers. Instead, I will help you find out the meanings they represent and explore the benefits to your measurements. What are the unique features of the Betasizer 2600 against other particle size analyzers? First, it has a high-power 10 mW laser, and it has 92 detectors, which covers a detection angle from 0.016 to 165 degrees. In addition, the Betasizer 2600 has 3 innovative technologies, including the combination technology of Fourier and inverse Fourier design, tilted sample cell technology, and refractive index measurement technology. Some features are easy to understand. Higher laser power and more detectors can bring higher detection accuracy and wider detection range to the instrument. But some features are not that obvious. What are Fourier and inverse Fourier design? And what are the benefits of combining them in only one instrument? And why is the sample cell be tilted? Why do we have to know the refractive index of samples? All of these features are very interesting and worth more explanations. First, we need to understand what Fourier design and inverse Fourier design are. Both designs are widely accepted by many particle size analyzers. The key to distinguish the Fourier and inverse Fourier design is whether the scattered light passes through the Fourier lens or not when it reaches the detector. If the scattered light passes through our lens before being received by the detectors, it's a Fourier design, and if not, it's an inverse Fourier design. For Fourier design, parallel light with the same direction will focus on the same point of the detector. For inverse Fourier design, accurate focusing can be achieved only at a small scattering angle, less than 5 degrees. As the scattering angle increases, the focusing arrow becomes larger, because a specific position on the detector does not correspond to a specific scattering angle, thereby reducing the resolution of the instrument. Both designs have their own advantages. Fourier design has higher resolutions, whereas inverse Fourier design has wider measuring size range. So if there is an analyzer that combines both designs on one instrument and has the advantages on both sides, why not? It will be a great technological innovation, and this is what the Betasizer 2600 does. Let's take a look at its optical setup. A laser beam produced by a laser device passes through the Fourier lens and then irradiates the particles in the sample cell to produce scattered light in all directions. The light signals are then received by the detectors placed in the forward, lateral, and backward directions. We can see that the lateral detectors are arranged in a spherical array, so that more detectors can be placed to have a wider receiving angle of scattered light, as well as save space. In addition to that, this Fourier lens is larger than a traditional one. On the one hand, it can increase the total amount of light transmitted, thereby enhancing the intensity of the scattered signals. On the other hand, with larger lens, the scattered light angle of the detector is larger, increasing the detection range of the instrument. However, the most important thing is that one Fourier lens has two uses. The center part of the lens collimates the laser, while the upper part converges the scattered light. And this feature brings a unique combination of Fourier and inverse Fourier design in the Betasizer 2600. Inverse Fourier design enables wider measuring range, and Fourier design leads to higher signal-to-noise ratio for ultrafine particles. As we know, cause particles scatter the light exclusively in the forward direction, and the forward scattered light is quite strong. So the forward detectors have a stronger light signal. Small particles scatter the light comprehensively in all directions, and therefore the back scatter light is much stronger than that of large particles. So the backward detectors have a stronger light signal. The Fourier lens of 2600 can concentrate the back scatter light of small particles and significantly increase the signal-to-noise ratio of ultrafine particles. This is the secret of its lower limit reaching 0.02 microns. In addition to talking about the combination technology, I would like to talk about another unique design of the Betasizer 2600, which is the tilted sample cell design. As we know, the effective receiving angle for scattered light has a critical impact on the measuring range of the instrument. Generally speaking, this receiving angle of an analyzer has two limitations. One is the Fourier lens diameter limitation. The smaller lens, the less scattered light that can be converged by the Fourier lens. But the inverse Fourier design does not have this problem, since it doesn't need to focus the forward scattered light in this optical setup. However, another limitation, the diameter of the sample cell indeed exists. The smaller the sample cell diameter, the more scattered light will be reflected inside the sample cell and cannot be refracted to the outside. This phenomenon is called total internal reflection. Total internal reflection is a complete reflection of a light within a medium such as water from the surrounding surfaces back into the medium. The phenomenon occurs if the angle of incidence is greater than a certain limiting angle, called the critical angle. This phenomenon happens in a sample cell as well. It causes the effective receiving angle for scattered light to decrease and overall reduces the detection range of an analyzer. Is there any approach to alleviate TIR? Yes, tilt the sample cell. By tilting the sample cell, there is less reflection and more refraction, as shown in the left figure. So, the Betasizer 2600 puts the sample cell at a specific tilted angle to reduce the impact of TIR and increase the receiving angle of scatter light. Compared with the traditional approaches, such as adjusting the position of the detectors or laser source, the tilted sample cell technology is an innovation. This technology effectively diminishes the effect of TIR and it leads to wide measuring range due to large receiving angle of scatter light. The last patented technology I would like to talk about is refractive index measurement technology. Refractive index is the measure of the bending of a ray of light when passing from one medium into another. It is essentially a material constant. For the mathematical fit for particle size analysis, according to Meyer theory, the refractive index of the sample must be considered. So it is a huge challenge to measure samples without known refractive index. To solve these problems, a tool to determine these sample parameters was developed by Betasize. It can measure refractive index, verify the known data of a material at a specific light wavelength. Most importantly, it provides optical parameters which are essential in particle size analysis. From the above introduction, we know that the Betasizer 2600 utilized the combination technology of Fourier and inverse Fourier design to simultaneously detect the intensity distribution of the samples in the forward, lateral, and backward direction. Besides that, the tilted sample cell technology is adopted in order to diminish the effect of total internal reflection and have a wider measuring range. Last but not least, automatic refractive index measurement is available in this analyzer. All these innovative technologies greatly improve the resolution and accuracy of the instrument. The advantages of this optical setup include high resolution and sensitivity, wide measuring range, and remember that this is one laser system, which can avoid the measurement errors caused by mixing of different wavelengths in the spectrum. The benefits of this unique optical setup are high detection resolution and sensitivity. For the standard sample measurements with different particle sizes, the Betasizer 2600 is qualified unquestionably. For two samples with similar particle sizes, distinguish these samples is always a challenge for particle size analyzers due to similar scattering spectra. In order to verify the resolution, we select standard samples of 5 microns and 15 microns for measurement, and uses a pipette to gradually add one sample to the other. With the addition of 15 microns samples, we can see that the changes gradually show up in the distribution curve, thereby confirming the high resolution of the Betasizer 2600. Now, I would like to introduce the biggest highlight of the Betasizer 2600, the modular design. It makes all measurements possible, either wet or dry. The Betasizer 2600 is highly versatile because it has up to 5 kinds of dispersion modules. Other than the main device, there are dry and wet dispersion systems available. For most common wet measurements, there is a standard volume module called BTAO2, whose dispersion medium is 600 ml, and there is small volume module as well as anti-corrosive module BT80N. For dry measurements, a standard volume module BT902 and small volume module BT903 are accessible. Small volume modules are designed for applications where the sample is valuable or produced in small volumes. Modular design of the Betasizer 2600 guarantees a quick and easy switch between the dispersion modules without inconvenient cleaning or troublesome hardware and software adjustments. Wet dispersion modules of the Betasizer 2600 contain BT802 small volume wet module and BT80N. BT802 automatic dispersion module is designed for particle size measurements using water as the dispersion medium. It has user-adjustable steering speed and built-in ultrasonic system to prevent sample agglomerates. Small volume wet dispersing module is designed for valuable or small volume samples, where the medium is organic solvent or water. It offers the maximum volume in 8 ml. Anti-corrosive wet dispersing module BT80N is designed for particle size measurements with organic solvents as the medium. It is suitable for common organic solvents such as ethanol, methanol, isopropanol, ether, etc. Dry dispersion module of the Betasizer 2600 include BT902 and BT903. BT902 automatic dry dispersion module is suitable for nearly all particle size measurements of dry powders. The gas used can be compressed air, nitrogen, or other noble gases. BT903 small volume dry dispersion module is designed for particle size measurements of valuable and small amount dry powders with a minimum sample volume of 20 mg. Why does the Betasizer 2600 provide so many dispersion modules? The answer is that the measurement approaches are so different because samples are different. And probably the biggest difference between measurement methods is dry and wet. It means what dispersion medium you should choose for your sample. If your sample is soluble in water and organic solvents, choose dry measurement, which uses air or other gases to disperse the particles. If your sample is soluble in water but not soluble in organic solvents, it is possible to find out an appropriate organic solvent as the dispersion medium. If your sample is insoluble in water and can be wetted in water, water may be a good choice. If necessary, you can choose energy treatment or select appropriate surfactants until the agglomerates are removed, and then measure the particle size distribution of your sample in a good dispersion state. The advantages of dry measurements include rapid operation, low cost, environment-friendly, and so on, whereas that of wet measurements are stable results, available repeatability tests, etc. You are free to choose the method that has the advantages you value. This is a selection guide to all dispersion modules. If you go with wet measurement, follow the left decision tree. If you go with dry measurement, follow the right decision tree. They can help you find out the best module for your measurement. By means of modular design, the Betasizer 2600 flexibly meets your needs for sample measurements. Now, I'm going to explain how the Betasizer 2600 complete a wet measurement and some important notes that you should know. When performing a wet measurement, the first step is to introduce the sample into the dispersion module. Add a small amount of sample a few times by yourself, and the analyzer will take over the rest of the work. How does the wet measurement work? With the recirculator stirring, the liquid circulates, and the sample dispersed in the liquid is transported to the sample cell. When passing through the sample cell, the particles are irradiated with a laser to produce a specific scattering spectrum, which is received by many detectors. Then, the light signals are converted into electrical signals and transmitted to the software for calculation. Finally, the particle size distribution of the sample is provided. Here are important notes when you are carrying out a wet measurement with the Betasizer 2600. The premise of accurate measurements is successful wetting. For hydrophobic particles, try to use detergents or non-polar solvents for wetting. Sample density and solubility in liquid must be considered. Some liquid and wetting agents for particular materials are displayed in the right table for your reference. And depending on the size and shape, external dispersion may be required, such as stirring and ultrasonication. Generally speaking, the smaller the particles, the higher the dispersion energy required. Let me show you an example of wet measurement. The particle sizing of chocolate. By measuring chocolates from different countries, we can investigate the sensory differences caused by their physical properties. The organic solvent methylolate is used as the medium for chocolate, and therefore a small volume anti-corrosive module BT80N is utilized. As we see in this figure, even small particle size differences in various milk chocolates can be detected by the Betasizer 2600 due to its high resolution and stable performance. Besides the wet measurement, let's talk about the dry measurement, a quite convenient and efficient method. In some cases, dry measurement has priority over wet measurement. For example, a liquid is not available. Quick analysis are required. When you have to analyze dry powders or see natural agglomerates. In these cases, dry measurement becomes indispensable, but only a dispersion module BT902 is not enough. The Betasizer 2600 comes with other accessories, such as air compressor, air filter, and vacuum cleaner. One of the great advantages of dry measurement over wet measurement is no need to use solvents or surfactants. Sample introduction is therefore more than easy. When feeding sample, the sample is pre-dispersed by a vibrating feeder, forced into a channel, and is conveyed by a venturi nozzle through the sample cell. The sophisticated measurement is followed by sample introduction. The air is generated by the air compressor and filtered by the air filter to remove the dust and other impurities to ensure the purity of the dispersion medium. Purified air enters the dry feeder where users introduce the sample. The sample is then delivered by the air and irradiated by the laser to provide specific optical signals, which are received by detectors and converted into electrical signals. Applying Mean theory to the signals, the specialized software calculates and provides the particle size distribution of the sample. Finally, the measured samples are collected into a vacuum cleaner for disposal, and the test is completed. This is the principle of dry measurement. Perhaps the most important note for dry measurement is to choose an appropriate dispersion pressure. In dry measurement, dispersion is carried out by three reactions: shearing, strong centrifugal and shear forces applied to particles due to airstream, particle-particle collision, agglomerates with high kinetic energy collide with each other, particle wall collision, the most effective dispersing effect, but it is possible to break primary particles if the air pressure is too high. With the increase of dispersion energy, the aggregated particles are slowly dispersed until they become a stable particle system, a perfect timing for dry measurement. If more dispersion energy is applied, the particles will be broken, and the measurement result at this time will be smaller than the actual value. All in all, the air pressure is crucial in dry measurement and should be investigated thoroughly when you perform the dry measurements with the Betasizer 2600. The last section is the automatic functions and software. One of the automatic functions is SOP, Standard Operating Procedure. SOP is available in the Betasizer 2600 to facilitate automated and standardized measurements, achieving operation with only one click in the software. Moreover, it reduces operators' workload, minimizes the errors caused by operators, and improves the accuracy and repeatability of measurement results. Auto-alignment of detector set. Another feature of the Betasizer 2600. It ensures the central point of detector is always on the focal plane of the Fourier lens, and the laser converged by the lens always illuminates the central point. This automatic function ensures the system is always at its optimal condition, and thereby guarantees the accuracy and reliability of measurement results. Auto adjustment of laser power. It controls the laser power intelligently to ensure the normal operation of the instrument, which ensures the long-term stability and accuracy of the instrument, extends the life of the laser, and reduces maintenance cost. The Betasizer 2600 comes with a specialized software. This software enables intuitive operation with orderly user interface. It has real-time mode for determining the optimal measurement conditions, automatic cleaning routine, automatic data backup, and highly customizable reports. The Betasizer software can export the particle size analysis reports conveniently in various formats such as PDF, Excel, text, etc. The reports provide comprehensive data and are highly editable and convertible. The Betasizer 2600 is capable of particle size testing in almost all situations and has broad applications in various industries like batteries, cement, ceramics, etc. It is a great tool to monitor the particle size distribution of materials to improve product quality, reduce energy consumption, alleviate environmental pollution, and protect human health. It has acquired International Quality Management Certification and European CE certification. The superior and stable performance of this analyzer has been recognized. Okay, we just walked through all the sections in this talk, like fundamental concepts, optical system, modular design, wet and dry measurement, and at last, automatic functions and software. Thanks to the powerful hardware and software, the Betasizer 2600 is able to navigate all the challenges of particle size measurements you may meet. This is the end for this presentation, and I hope you found this video helpful. Please be sure to leave any comments or questions below, and check out the Betasizer website for more product information. Thanks for watching.